In this video, I'm going to talk about covalent compounds. Now remember, there are two types of compounds that are present in chemistry that we talk about: covalent compounds and ionic compounds. Ionic compounds are a transfer of electrons, and covalent compounds are important that they don't transfer electrons, instead they share their electrons with each other. And more importantly, you can always distinguish a covalent compound from an ionic compound because covalent compounds are composed only of nonmetals. So if you have a compound that is only composed of nonmetals, you have a covalent compound. So there are no metals present in a covalent compound. So two key things about covalent compounds: they're composed of only nonmetals and that they share their electrons. Now, covalent compounds will form, when they share those electrons, they will form single, double, and triple bonds. So if we think about the two nonmetals kind of sharing those electrons, the more electrons that they're sharing, the greater the attraction is going to be between those two atoms. And so therefore, a compound that is sharing more electrons is going to have a greater bond energy. So if we remember, when we were doing Lewis structures, single bonds have 2 electrons that are being shared, double bonds are 4 electrons, and triple bonds are 6 electrons. So whenever you have two nonmetals that are bonded by a triple bond, then that means there are 6 electrons being shared between them. And so that's going to be a greater bond energy than one that just has 2 electrons. And so the 2 electrons is going to have a lower bond energy. The 6 electrons are going to have a greater bond energy. So single bond is lowest, triple bond is the highest whenever we're talking about the bond energy, because there's more electrons being attracted. Now, because there are more electrons in a triple bond, that's going to make the bond length even greater because there's that greater attraction between the bond. So the bond length is going to be the shortest for a triple bond, and it's going to be the greatest for a single bond. So in summary, the bond energy is going to be the greatest for a triple bond, lowest for a single bond, and the bond length is going to be the greatest for a single bond and lowest for a triple bond. Now, what about properties of covalent compounds? So there are two types of properties: physical properties and chemical properties. The physical properties of covalent compounds are very different from ionic compounds. For one thing, covalent compounds will all form, some of them do form solids at room temperature, but they're mostly gases and liquids. And those that are solids at room temperature are usually considered to be very soft solids. So think about a wax. A wax is a soft solid and is a covalent compound. But most gases and liquids are covalent compounds. Also, covalent compounds have relatively lower melting and boiling points as compared to the ionic compounds. What about chemical properties? The chemical properties of covalent compounds is that one of them is when they dissolve in water, they stay together. They stay together as molecules. And so that's also why we call covalent compounds molecules, whereas ionic compounds are considered formula units because ionic compounds, they dissociate or break apart into its ions in water, whereas covalent compounds, they stay together as molecules. Also, covalent compounds will form very large complex compounds. And so those large complex molecules that can form is an important chemical property that covalent compounds can exhibit.